Welcome to the 24 Hours of Pass Summit preview. We are excited you could join us today for Grand Prix session, Query Performance Tuning in SQL Server 2014. This 24-hour Pass event consists of 24 consecutive live webcasts. Session will be recorded and posted online soon after the event. My name is Victor Rios and I'm a SQL Server administrator, father of family and husband. All of this knowledge, experience, and feelings have helped me to face up the daily IT task and solve this. I think that 24 hours of Pass is an event so useful to improve our SQL Server skills. Now, I have a few quick introduction slides before I hand over the reins to Grant. He will speak for 14 to 45 minutes and will move on the questions where you can ask any question you might have. If you have any issues, type your issues into the question pane and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your question in the QA field at any time. The question pane is located on the right side of your screen. Once we get to the question and answer portion of the session, I'll read off your question to the speaker. Note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will show up on your screen. I'd like to take a moment to thank you, our event partners. The staging of 24 hours of Pass would not be possible with their support and dedication. They are the reason that this event is available free of charge. Thank you, our presentation sponsors, Microsoft and Dell Software. Next, as you all may know, this 24 hours of Pass is a preview of Pass Summit 2014, the largest conference of SQL Server and BI professionals, with over 5,000 attendees representing 2,000 companies from 52 countries. Summit is time to share, connect, and learn with your peers and industry partners. Pass Summit is not only a week of intensive learning and knowledge sharing that all offer strategic insights. It's a time to network and rub shoulders with your industry experts. Taking place in Seattle from November 4 to 7, Pass Summit will offer over 190 world-class sessions across 5 topic tracks. These 24 hours of Pass session provide a mere glimpse and what you can expect from Pass Summit. Find out more at www.passsummit.com. And if you register by September 26 using discount code 24HOP14, you get $200 of the registration fee. And now please allow me to present the speaker of the hour, Grant Pritchett. Hello, Grant.
Hi, how's it going? Victor, is this thing on? Hello?
Yeah. Hello,
okay.
Grant.
All right, are you all set?
Yeah, I'm here.
Is there anything else you need to do?
No.
Oh, okay, great. Let's get started.
Okay.
Okay, cool. All right, so we're going to talk SQL Server query performance tuning, and we're actually going to go through an optimization checklist. That's the plan. And I'm doing a 7-hour full-day pre-con at PASS. It's a full day of query tuning. We're going to be talking about execution plans. We're going to talk about the query optimizer. We're going to talk about identifying common problems, how to fix those common problems, how to collect information. And frankly, I can't give you all that information in an hour. So what I've done instead is I've put together a checklist, a bunch of items that you can immediately hit to go through and take a look at to understand where you might have problems, where you might have issues. These are fast, easy, low-hanging fruit, stuff you should avoid, stuff you should start doing, stuff you should continue doing. Right at, whoops, sorry, bad presenter. So at Summit, I'm going to go through 3 sets of goals. We're going to understand how the optimizer works and understand how that's going to help you write better T-SQL. And then we're going to spend a lot of time with execution plans. I'm an execution plan freak. I love them, mainly because they help me so much when I'm talking about query performance tuning. There's just no other way to understand what's going on with the optimizer except through those things. And we're also going to talk about common performance problems, some of which we're going to hit tonight. Please, please, please get in touch with me. This is my contact information. My name is Grant Fritchie. I'm the Scary DBA, and this is my email, this is my blog, this is my Twitter handle. Just if you've got questions, I live off of your questions. Please get in touch. I answer every question, I promise. The answers might be short, but I respond to all my emails. I always do. So please get in touch. If you've got issues, I need to know what they are. I'm here to help out. I'm a SQL Server MVP. I've got 20 years of experience, more than 20 years of experience in the industry, and I love helping where I can. One note, side note, before we get going, there is we're raising money for Doctors Without Borders, and it's well, anyway, Adam Mechanic, Brent Ozar, Steve Jones, and myself have committed that if we raise $10,000, we will wear these leggings at PASS and get our pictures taken. And really, 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 we would like to raise that money. It's completely money for charity, for a needed charity, and we're going to do something silly to help you guys get together and get that money for us. So please donate. Here's the link, and then you can enjoy the silly pictures later. All right. So here's the deal. I'm going to make a whole bunch of suggestions tonight. A number of different things I would like you to do, a number of different things I would like you to avoid. But understand, your situation is different than mine. Your servers are bigger than mine or smaller. Your workload is bigger than mine or smaller. Your workload is more diverse than mine or more simple. So you need to test everything I'm suggesting that you do. And I'm serious when I say test this stuff. I'm going to give you a lot of information, but I don't want you to take it completely at face value and apply it blindly. I sincerely want you to test this. I sincerely want you to validate that this information is accurate, that you're getting good data, that you're getting good improvements on your performance, because situationally, some of the stuff I'm going to suggest won't work as well at some times. So you need to test, 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 test. You cannot simply trust that this is good information. You've got to validate. Lewis Davidson recently in a presentation I was at said, he wishes we could turn the spam song into the test song, right? Test, 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 test. Please test this stuff. Make sure it really works. We're going to talk about performance tuning. We're going to talk about query tuning, and we're going to spend a lot of time on this. But understand, again, back to that testing thing, there are exceptions. A lot of these rules are not hard and fast. They are fairly vague. Unfortunately, I wish query tuning was a simple science. 2 + 2 = 4. But it's not. There's just a complexity to it because of the complexity of our data structures, because of the complexity of the SQL language. Your hardware is different than mine. You may have, that 4, it can only be 4, right? 4 terabyte server. I don't. You may have more memory than me. You may have better CPUs than me. That hardware changes can result in differences in behavior, so you need to keep an eye on that. I'm pretty sure I mentioned before that testing is probably a good idea, so anything I suggest, you want to go through. Also, it's a really good habit to get into making small changes. Don't do 15 things, do 1 or 2. Understand what happened, measure, evaluate, and then do some more changes. Incremental changes are better than large, vast changes. Even if you know for sure that those changes are vital and important, you may want to break them down into smaller chunks to ensure that you can appropriately test. You're going to have to monitor your servers. You cannot simply rely on the fact that, well, granted, doing this makes performance faster, so it did. You need to validate that stuff. Again, that goes back to testing. So let's talk about it. You've got servers. Now, servers pretty much consist of memory, CPU, and disks, right? Let's talk memory. Look, the year is 2014. The days of 32-bit are over. The last 3 laptops I have owned have all been 64-bit. My tablet is 64-bit. Your servers should not be 32-bit in this day and age. It's time to move on. Get away from those 32-bit things. Dynamic memory is important. SQL Server will work within a dynamic range. It will allow the OS, to give and take some memory, but it's very important to set a minimum and maximum value. You do not want to deal with having the allocations go too low or too high. So you want to make sure that you set a min and a max on a regular basis. You also want to use optimize for ad hoc workloads. This is a free setting to all intents and purposes. Every single test I have ever seen has found no major shortcomings in using this, and it does help. What it does do is the first time a query is passed in, instead of creating a full execution plan and storing that plan in memory, it simply creates an execution plan stub that it stores in memory. The second time the query is called, then that stub is fleshed out to a full execution plan and stored in memory. Now you get a full execution plan. It's not like it's doing something weird with the optimizer. It's just that in all these ad hoc one-time queries that are never, ever, ever going to be called again aren't stored in memory as a full execution plan. They're stored in stubs. And so that makes things a little bit more, easy to manage and certainly better for memory. And yeah, I do recommend you enable it on all servers. All right, so let's talk CPU for a second. Set the cost threshold for parallelism. The default value is 5. That is a ridiculous, insane default value. It is way too low. Just flat out, it is too low. I realize and I recognize and I advocate that the defaults are usually the way to go with SQL Server and with most Microsoft products. Microsoft does a good job on defaults in most circumstances, but this one is one of the exceptions, sort of like the exception that proves the rule. 5 is just bad. I would suggest, and again, we're going to test this, right? Test, 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 test. I would suggest for your OLTP workloads, I would set that cost threshold for 45. For your reporting systems, I would set it 25, and then I would adjust from there. Cost threshold for parallelism, just so you know, is the estimated cost of a given query. It's not an actual measure. It's an estimated cost. So it's a mathematical construct, and that mathematical construct could be very, very much higher than 5, while that query could run very quickly. You could be seeing parallelism for queries that just are not going to benefit from parallelism because of this cost threshold. Now the max degree of parallelism, I see a lot of people will set it to 1. in order to avoid parallelism? Well, first, make sure you've got your cost threshold set appropriately. People will leave the default value of 5, and then they will see lots and lots and lots of CX packet weights, which is not necessarily a bad thing, but that will cause them to say, oh my gosh, I've got bad parallelism occurring. I'll set my parallelism to 1. I don't recommend that. I really strongly recommend you don't set it to 1. The default is 0, which means it will use all CPUs. Personally, I would suggest that you set it to 0 initially, and then as you find you may or may not have some types of CPU problems, you can make adjustments from there. I would also suggest you consider using the query governor. There's not a hard and fast rule around that, but frankly, occasionally from certain developers, from certain database developers, from certain DBAs, you're going to get some questionable queries. And you might be better off using the query governor to ensure that a limited amount of resources can go to those queries. You set a cost limit, you work within that cost limit, and then that will allow you to reduce the amount of CPU you're using. Now storage, well, I mean obviously TempDB, you need to separate that storage out from the data where possible, when possible. I recognize that a lot of people are dealing with very small servers, probably still 32-bit servers, but and probably everything's on a single drive. I would get away from that where you can, especially if you're hitting performance issues. TempDB is something that's problematic. I would also recommend you look at multiple files. Now, for exactly how many files, frankly, go to Jonathan Cahaya's, go to Kim Tripp, go to Paul Randall, look at their blog. It's on SQLskills.com, and they'll give you some good advice on how to set that up. Do not go with the old thing of the number of files is equal to the number of processors. That is not accurate. It is an old saw. It's been disproven multiple times. Make sure that you're setting up equal-sized files. Don't try to mess around with breaking these things down in small chunks, because it will mess with the way that the performance behaves. I also recommend for storage turning on compression where you can. Compression is amazing. Most people have minimal CPU use. Very few people are hitting CPU maxes. They're bound usually on storage, sometimes on memory. So you sacrifice some CPU and increase your storage speed. At minimum, I would go for index compression, but probably I'd go for the storage compression too if you can. And yeah, that can be a enterprise-only feature, and so people running standard, you might not be able to get at it. Sorry, if you can't get to it, you can't get to it. But if you can, I suggest enabling it. And more disks are better. Or more disks is better. Who wrote that? Anyway, more disks are better, and simply throwing hardware at the problem can solve a lot of query performance problems. But only if you've got controllers as well. Simply throwing lots and lots of disks through a single controller just means you've moved the bottleneck slightly, and you're probably not going to see a big performance gain. All right, so now that's just some general hits in and around the server. It's not my area of expertise, but these are some safe things that I strongly recommend. Let's talk about administration. Statistics are vital. Statistics run the query optimizer. Without statistics, well, the optimizer makes guesses. SQL Server 2014 makes some slightly better guesses, right, because they've improved the cardinality estimator for the first time since SQL Server 2000. The cardinality estimator, the thing that figures out how many rows a given query is going to return, is all new. But it's still driven off statistics. And so you need to make sure your statistics are up to date. I absolutely believe in auto-create and auto-update. They are the way to go. But frankly, they are not enough. You're going to hit certain types of workloads that you're going to run into issues where Simply allowing the auto create and or the auto update to run is not enough. You're going to have to do manual updates as well, and that means running, update statistics or the function SP update stats. You might need full scan. Situationally, that's a great way to go. And in 2014, we've got a new thing going with partitions. You can do incremental, which will update the statistics individually across those partitions. Again, something to test if you're in that situation. If you're not in that situation, don't worry about it. Make sure that you're defragmenting your indexes. I find in most situations, index fragmentation is actually not that big a deal for performance. It just doesn't slow things down radically in most situations. But depending on the server, depending on the data load, index fragmentation can be a pretty major hit. So you're going to want to be able to go in there and check that. The number of pages in your index absolutely matters. If you've got 8 pages or fewer, it's only going to be stored on a single extent or possibly on a mixed extent. And in that case, you can't really fragment it, and you can't really defragment it. So don't worry about those at all. The general suggestion is 1,000 pages, and that's acceptable, but I've seen performance improvements all the way down to about 100 pages, depending, again, on the system. So testing, testing, testing. If you haven't heard the word testing enough tonight, I guarantee you're going to hear it some more. And yeah, I do want to point out, it's 1,000 pages is not the magic number. It's a good default, but you can go lower if you need to. And I have done so, and it does help, depending on the situation. You just can't go below 8, ever. All right, more administration. Avoid the dangerous settings, like, oh, I don't know, auto close. When the last connection is available on that server, it completely shuts down the database, meaning the next time someone tries to connect to it, it has to start that database back up again. That is a huge performance hit, gigantic. If for no other reason, it's going to remove all those queries from cache, and you're going to have to recompile everything right from scratch. That's pretty awful. Auto shrink. Auto shrink is just not good. Auto shrink causes problems. If nothing else, I'm told that every time you shrink a database, Paul Randall rips the wings off of an angel. I don't know if that's true or not, but auto shrink is something that you need to avoid because it leads to massive fragmentation at a low level at the OS and not something that you can easily defragment. You're going to have to go in and mess with the files themselves, taking your server offline. So it's something you just want to avoid. Look, the profiler is a glorious thing. Trace events are great. I've used them for years. I've been in love with them for years, but their time has ended, right? Extended events, it's time. Hopefully earlier today you saw, I believe, Jonathan Casillas and Aaron Stellato did a session on extended events, and hopefully you got to see it. If not, definitely check out the recording or go to the PASS Summit and see what they're going to be talking about there. But extended events are amazing. They are glorious. Yes, trace events work well too, just not as well as extended events, just flat out. If nothing else, think of it this way. Extended events filters at the event level. Trace events captures every single event and then filters after they capture the events. If nothing else, that should make your determination as to which one is better for you. But if you have to use trace, and if you want to use the profiler GUI, do not point that profiler GUI at production systems. It uses a different buffering mechanism, and it will negatively impact a production system, especially if you're using this for a system that's already under stress, a system that's already under load. You're going to be adding in a negative way to that load and that stress on that server. And the information you gather could be hurting the server worse. So you need to avoid that. If you're going to use the trace events, make sure you use the scripts to generate T-SQL so that they output to file, and then you can consume those files with the profiler GUI. The profiler GUI is handy for reading those files. Not quite as good as the GUI in 2012 and 2014 for working with extended events, but it's pretty good. However, you run those things and then you can consume them with the profiler GUI, but we don't hook that directly to the production system. All right, that's enough system stuff. Let's start talking query tuning, and funny enough, query tuning starts at database design. Database design, oops, comes into a series of areas: storage, constraints, and indexes. All right? You have to decide how you're going to store your database, you have to decide the constraints, and you decide the indexes. It's all a fundamental part of the design. And let's talk storage. Yes, separate your login data. Put them on different disks. Make multiple file groups. Split your data up into different file groups in order to change the way SQL Server can read from that stuff, write to that stuff. Even on a single drive, this makes a difference. Now that difference is very small. You're not going to, oh cool, we add a file group, all our performance problems go away. Not even close. You're going to still be seeing pretty major performance issues if you've got bad code, if you've got missing statistics, if you've got missing or incorrect indexes. But splitting up the file groups gives SQL Server multiple access points on the disk, and you will see some small performance gains. This one's controversial, but I'm a fan of it. I don't like autogrow. I recognize it as a safety valve, but what I would prefer to do is maintain the systems and keep an eye on them, monitor them, set the database to a big size so you have plenty of headroom, plenty of room for it to grow, and then let things go along that way. It's controversial because you could lose transactions if you don't have autogrow on and you're not monitoring the systems, or you get some massive spike that fills the data, and you could lose transactions, and so therefore it's something of a problematic suggestion. But I'm not crazy about the way the thing is set up, and this is another situation where the defaults only make sense for really tiny databases. You get the large databases and you've left autogrow defaults in place. You've got serious fragmentation. You may be seeing lots and lots of growth events over and over and over again, and every growth event leads to waits, and I'm just not a huge fan. If you're going to put autogrow in place, I would strongly recommend fixed growth and finding that magic number through testing that allows you to grow your files enough to ensure that you've got space without growing them so large that things are waiting while the growth occurs. I'm just not a fan of autogrowth, just because I see more hits than I see helps, frankly, with it, if you've got good monitoring in place. If you're unable to monitor your servers or unable to adequately respond when there's issues around your servers, you may want to turn that back on. Let's talk constraints. Database normalization, absolutely, 100% is a performance benefit. It is not a performance cost. Appropriate normalization helps SQL Server performance. SQL Server is a relational storage engine. Therefore, it is designed around the concepts of normalization. It is not an ID value pair database. It is not the new document DB. Those things are built for looking up, give me an ID, I will give you a full set of data. SQL Server is not built around that. It is built around the concept of normalization. And because of being built around that concept, it benefits from normalization. You will see differences in execution plans because of normalization. You will see differences in the size and amount of data that you store because of normalization. Reducing the amount of data that you store means more data is stored on a given page, which increases performance. It's absolutely a part of normalization, and you have to keep that in mind. You need to enforce your constraints. With no check on foreign keys means it's an untrusted foreign key, And that means that the optimizer can't assume a guaranteed row, and so you may see scans where you would have gotten seeks. Primary keys are vital. I've seen tables with no primary key. How can you know what data is stored there? You can't. It's just, willy-nilly. And we're assuming that the application is going to somehow keep track of and eliminate duplicates. And frankly, human beings being human beings, mistakes get made. Unique values. If the optimizer knows a given value is unique, it will make different choices in the optimization process, which will result in different performance values. So you need to keep those in mind. Indexes. You get general and specific. All right, narrow. Well, okay. Narrow is hard to define. How narrow is narrow? Well, as narrow as is practicable. A lot of people say as narrow as possible, and I don't entirely agree there. I believe in narrow. I believe in tight little indexes as much as you can, as much as is practicable within the situation that you are in. That said, there's nothing wrong with 2, 3, 4 ints as an index, a couple of date columns as an index. Those key values, if they are usable to your queries, are practicable. They may not be as narrow as possible, but they are narrow within the constraints of the system that you're designing, and that's what you want to aim for. Integers actually work better. It's kind of weird, but they do. Why? Well, it's easy to understand. SQL Server runs on a computer. Computers consist of what? Right, numbers. Other choices can work well too, right? Don't be scared of that date time, which by the way is stored as a number, so it's easy. Don't be scared of that varchar necessarily, depending on the size, depending on the length, depending on the selectivity of the data within it. But don't be scared of those choices, but you will see, you honestly will see better performance with injectors, with integers. You need to choose the leading edge very carefully. You've got a multi-column constraint, or a multi-column index. That's fine, that's good, but that first column is the column that's going to be used to make the statistics, specifically the histogram in the statistics. And because of that, you want that in general to be the most selective column, to be very distinctive, to be very useful to the optimizer so it can understand, hey, given this value, how many likely values will I get back from this table? So that first edge, that first column, it's a very tough choice. You can make indexes with a bit column. I generally wouldn't recommend making it the first column. Make it with the second column, third column in a multi-column index, and you can see some great performance because of that. It can help. It really can. But the leading edge is that driving factor with the histogram, and if you have a very non-selective index there, it can be an issue. Covering indexes are fast, and they are faster. Frankly, covering indexes are generally faster than a clustered index, generally. All things being equal, lots and lots of stuff, lined up. But that said, you get one clustered index, and so you have to pick that wisely and choose it carefully. And you can't create a covering index on everything. Trust me, don't do that. People have tried. I've seen many systems that do it that way, and they run into lots and lots of issues. But a covering index is really good. All you have to do is use the include, add extra columns. It does add to your storage overhead. It definitely is going to add to inserts, updates, deletes, but you're going to see some performance improvements from it, so you want to take a look at those. Now the clustered index, remember, you get one. Make it as narrow as you can. Again, as narrow as practicable. The same rules, the general rules apply to the specifics here. In general, I would design around the clustered index. When I'm building out databases, when I'm building out the tables in those databases, I pick the clustered index as part of the database design. It's just a general rule of thumb. And also what I would do is I would use the most frequent access path to the data. Find that single point that most of the application is going to use. That could be the primary key, but it might not be. It could be a foreign key. It could be another column. And if that column is good and selective, it's got a good distribution, best of all if it's unique, that makes a better clustered index if it's the most common access path to the data. And the reason that is because clustered indexes are the data. They are the table, right? All the data is stored at the leaf level of that clustered index. So using that single point as the most frequently accessed path is the best way to go. When rebuilding a clustered index, use drop existing because that will allow you to rebuild it faster. And you should avoid columns that get updated really frequently for the cluster because those data changes have to get boiled down to all the non-clustered indexes because the clustered index key is used by all the non-clustered indexes as lookup values. So you want to be careful about that. So while that varchar field might be a great candidate for a clustered index, if it's going to be updated on a regular basis, that might eliminate it. So again, you want to test this out. See what works in your situation. All right, T-SQL coding. Some really simple rules, and they're not hard, and they're old. This is boring, old, dull stuff. Return the data you need when you need it, right? Don't run select star because maybe we'll need the other 4 million rows when I really only want to look at one, right? Get the stuff you need when you need it. There is nothing wrong with an ORM tool, nothing. In Entity Framework, in Hibernate, these make great software, and they do wonderful things. They create parameterized queries. Parameterized queries are awesome. Or stored procedures, either one. The reason I say this is because if you're just using ad hoc queries, dynamic queries, these built-out queries with hard-coded values, you're going to overload the execution plan cache, and you're going to see memory issues. So using parameterized queries is cool. It works the same way as stored procedures. There's no difference in behavior between parameterized queries and stored procedures, at least not effectively from a query tuning standpoint. So what the heck, go for it. Mainly, it takes advantage of parameter sniffing. And yeah, parameter sniffing is a good thing. Parameter sniffing is something that occurs all the time with parameters, either stored procedures or parameterized queries, and it uses a specific value against your statistics to create the execution plan. And it occurs for every single parameterized query and every single stored procedure for every single table, and most of the time, that's a good thing. Every once in a while, parameter sniffing turns you around and stabs you in the neck, but that's bad parameter sniffing, and we're going to talk about that another day. Avoid cursors, and yes, while and loop are the same thing as a cursor, so avoid those things. They really do. It's Jeff Moden called it rebar, row by agonizing row. Don't do it. Qualify your object names. It's a silly little thing, but it reduces a certain number of lookup costs. It's a very low level, teeny tiny benefit, but it's accumulative, right? You save a microsecond, but you save, million microseconds. Hey, guess what? You just saved a second or two. Cool, let's keep doing that because that all adds up. And avoid using SP_star for procedure names because it runs into issues too. It's not that big a deal, but it's simple rules. Let's avoid them. We don't have to hit the master database that way. Non-chargeable conditions. Functions on columns. I wrote a blog post recently about the whole left-right thing. Regardless, a function on a column. Now, certain columns, certain functions are okay depending on how you use them. Using percent anything with a like statement is bad, but using like anything percent is okay. Why? Because it's able to use the leading edge of the index, and it's able to use the leading values in the index and the statistics within that index. But this way, it has to do scans, no choice. Set no count on, it just reduces the number of returns on the network. You're going to see fewer round trips for the queries. Do not nest views. Views are great, nothing wrong with views, great way to obfuscate code, make things easier for people to access. But when you start joining view to view, when you start joining nesting views, it gives the optimizer fits because the optimizer has to go through all these objects in these multiple views, and they may be duplicate objects referenced multiple times from multiple different locations, and put this all together and then try to simplify, and it frankly will run out of time, and you will get bad execution plans because you've just given the optimizer too much to do. I should probably try to make this a little nicer and say, avoid optimizer hints or minimize optimizer hints, but I just feel more comfortable saying don't use them. Just don't do it. Because it's frankly, people overuse them. In a given situation with a given set of circumstances, an optimizer hint will work well. And so then they'll put it everywhere. And it's just be careful. I would rather say don't use them, and then we'll very selectively find the places where they work well, than suggest that, well, consider them. Now, make it the last possible thing on your list, right, after you've paid a consultant, right? Pay the consultant first, then consider using optimizer hints. Because, frankly, they cause problems, especially no-lock. No-lock is a monstrous thing. It causes issues. We can talk about it at length. I'm not going to be able to cover it all here. Where possible, try to avoid recompiling execution plans. That means, again, going back to stored procedures and parameterized queries, because then you're not passing in hard-coded values which are resolved as different execution plans every time. In some situations, temp tables will lead to recompiles. In some situations, a table variable will avoid the recompile, and so you want to use those in places where the recompile is hurting you. But you have to be careful about table variables because they can cause other problems because they don't have statistics. And as we've already said, statistics are a driving factor on how the optimizer works. Make sure you've got ANSI standards on your connection settings, and make sure you don't change those ANSI settings within a statement, because again, that can lead to recompiles. Lead to recompiles. Yeah, okay, hey, look, I said that already. Don't change them within a query. Make sure you don't interleave data definitions with data manipulation, meaning you create a table, then you put some data in, then you modify that table. Again, you're going to get recompiles, and recompiles are frankly a hit on the CPU, and could be a hit on memory, and could be a blocking or locking issue. So it's just stuff to avoid. Adopt best practices for transactions, which basically means keep them tiny, right? As short as possible. Again, that doesn't mean as short as you possibly can. Probably should say as short as practicable here, but as small as you can within reason. And make sure that you set the transaction abort on. I mean, that just should be something you set on. And consider, where possible, using read committed snapshot. It does add additional load to TempDB. You must be prepped for that, but it reduces contention in a safe fashion, unlike no-lock, right? Multi-statement table-valued functions are evil. E-V-I-L. They are evil. They have no statistics, and which means the optimizer makes poor choices. Prior to 2014, it assumed one row. After 2014, depending on the table value, depending on how it's being referenced, it may assume 100 rows. One row is great if you're only returning one row. If you're returning two, it could be a problem. 100 rows is great if you're returning 100, but if you're returning one, it could be a problem. Or if you're returning 1,000, it could be a problem. That lack of statistics makes these things problematic. Further, the execution plans are lies. They show you this little table scan thing. It has a cost estimate of 0. Why? Because it's assuming a single row. But if it's returning 1 million, 10 million rows or something, trust me, it has a very high cost. Even if the optimizer is guessing at 0, it's just because these things are evil. It's also not showing you what it's actually doing. The processing is there. There's a way to query them. By the way, I'll show you that in the pre-con. There's a way to query and get that execution plan for that function, but it's hidden. It's put away. And whatever you do, oh my God, please do not nest these things or join them. Functions calling functions, which join to functions which call other functions, is absolutely a straight path to performance nightmare. Multi-statement table-valued functions are evil. Now, that said, table-valued functions inline single statement are not. They are optimized appropriately, they're integrated by the optimizer, and they work fine. Yes, you can still write bad T-SQL with them, don't get me wrong there, but just as a general object within the database, they are not evil, whereas these things really are. Now, I've just given you the horror show of things to avoid, stuff not to do, stuff to make sure you're doing, but really, chill. It's okay. Most of this stuff is straightforward. It's not that bad. You can get online, figure out what's going on. There's plenty of ways that you can get in here and modify these things. There's plenty of ways that you can add an index, modify a given index, update your statistics. You can get help. You can go to Stack Exchange. You can go to SQL Server Central. You can go to the MSDN forums. You can tweet, hashtag SQL help, and you will get assistance on this stuff. So it's not like you're on your own here. You're going to be able to track down help. Now, just the one thing about relaxing, though, don't relax too much. Make sure that you are testing all this stuff that I've been suggesting for the last 45 minutes here. Test everything. And hey, please, you want to talk about this some more? You really want to drill down? You want to get into how the optimizer works? Sign up for my seminar. Let's talk about it. Now, do we have any questions? We've got a few minutes here at the end. I'm only 3 minutes over. I feel good about that. So how would you, what happens when, why does, when do I? Victor?
Okay, thanks, Grant. Scary
Oh,
man. I forgot to present you. I am so upset for that. So what you are?
Don't worry, it's fine.
Yeah. So we have some questions, some interesting questions. Some of them is we have 3 SAN storage area network volumes for our DB servers, data, tlog, teamdb. Since these are all on the storage area network, is it still considered having teamdb move away from these database files?
Right. Okay. Time to take your SAN admin out for frothy beverage of some sort. Yes, it is separating them out. But depending on how your SAN admin has set up your disks, it's possible that it's not separated. So you need to make sure that you talk to your SAN team to ensure that the disks are configured well. And frankly, you're going to have to phrase that question carefully when you talk to your SAN team, because you walk up and just say, hey, did you make my disks correctly, is pretty much questioning whether or not they know their job. And I would assume, unless proven otherwise, that they do know their job. And so you want to ask that question. It's like, hey, can we talk about how my disks are configured? Just because I'm learning this stuff, I want to figure these things out, and I want to make sure, I just want to know how you got things configured so I know that they're set up the right way. I'm assuming you got it right, but can you help educate me? That's a much better approach. But you're going to have to talk to your SAN admin to find out how they've configured the disks. Most of the time, yes, you're completely safe, but you want to, Ronald Reagan said it, trust but verify.
Okay, thanks, Grant.
Sure.
We have another question. We have queries that run fine on their legacy optimizer, but on the version 2014, they run 30 times slower. How do I troubleshoot why that is happening, and what will be the fix other than turning on trace flag 9481?
Oh, wow, you got the trace flag too. That's great. By the way, that is one possible fix. Probably you are hitting a situation where the new cardinality estimator is changing the execution plan. The first thing I would do is I would get the execution plans, get the old one, get the new one, understand what the differences between the two of them are, why the optimizer is making those choices. Maybe your stats are just out of date. Maybe. Maybe there's a different choice in indexes that you can make. Maybe. Maybe you're hitting a problem because the new cardinality estimator is making, frankly, I would say in most cases better choices, but different choices certainly. And in your case, those different choices are hurting performance on your queries. And if that is the case, then you will need to go to those trace flags. And that stinks, but at least you've got a possible out. But I would definitely look at the execution plans, look to the statistics, look to any other tuning opportunities first, and then the trace flag as a last resort.
Okay. One question. Given a server with a certain number of gigabytes of RAM, which is the criteria of the percent to set the minimum and maximum for SQL Server?
I'm going to defer again to Jonathan Casillas. He's a much smarter man than I am. He had a pretty simple rule. It was I'm going to get this wrong, so please look it up and validate it. Don't trust me, but I believe it was for 16 gigs. It was 2 gigs for the OS, and at 32 gigs it was 4 gigs for the OS, and then beyond that there was a formula applied for a certain number of gigs, a certain amount of space. Again, I believe I got that incorrect, so I would double check that. But yeah, he's got a very simple and straightforward formula for it. That's well tested, so that's why I trust him. Again, it goes back to testing, so that's what I would suggest.
Okay, and some recommendation for locked pages in memory?
For lock pages in memory, I'm going to go with the very safest answer there and say I don't know. I've run into so many situations around that. I've read white papers that say it's the greatest thing since sliced bread. I've read white papers that say, oh my God, never do that. I've read white papers that say only do it in certain situations. And I'm not convinced that people know. So my best answer is I don't know. I would suggest testing it in your environment and seeing what do you see in the situation you are in. And further, I'll bet you server to server within your environment, depending on the workload, you'll see differences in behavior. So you're going to want to make adjustments around that.
Okay. Well, there are a lot of questions, but the time is finished. But yeah.
Sorry, I love this stuff. So I'll keep talking about it all night.
Okay. So thank you for Grant and share all your knowledge, 20 years plus of experience, and all your developer experience is so interesting. And well, you are in the summit, and let me see. Okay, you are offering a catch, getting a started reading execution plan and full presentation of this pre-conference query performance tuning in SQL Server 2014 at PASS Summit 2014. And don't forget to use the discount code 24HOP14 to save 200 on PASS Summit registration. So, well, thanks, Grant, and so interesting your presentation and all your experience.
Well, thank you. Appreciate it.
Okay, and thanks all. We have another webinar with Jess Borland, and in a couple of minutes. Thanks all. We have some time.
Yeah, we've got a couple of minutes here. You want to answer a couple more questions while we're still here? I mean, people are leaving, I've no doubt. I haven't looked, but
Yeah. Okay.
But hey, by the way, guys, Jess, if anybody who's still here, Jess Borland, she rocks. So you should definitely go and see her session. I'll bet it's great.
Okay. We have one question about the CX packets. So we have a production server with cost threshold of parallelism set to the default value of 5. CX packets weights account for 50% of the weights, but users have never complained about performance. So should I mess with this setting?
I would anyway. The fact that users aren't complaining about performance tells you one thing about CX packet weights. It's an indication only of context switching and weights while the context switches occur, and you actually don't need to worry about that weight stat in and of itself and all by itself. With no other indications of performance problems, CX packet weights are not an indication of a problem. But that default value of 5 is still too low. And whether or not you're seeing lots of performance problems, I'll bet you're seeing some performance problems caused by that low threshold. And so I would bump it up, yes. Again, test, validate, ensure that this is going to help you and not hurt you. Frankly, I've never seen it hurt anybody, but I would validate it, ensure that it's okay. But I would still suggest moving it up. Yes, even though your users aren't complaining, I would move it up because it's a bad default.
And the last one is for cluster index. Why the cluster index should be narrow?
Well, any index should be narrow in order to ensure that it's got a small amount of information on a given page. Because the way indexes are stored on a balanced tree, there's a certain amount of stored on each of the pages in that tree at each level. And the wider the index is, the smaller the amount of information can be stored on any given part of the tree, and therefore the larger amount of the tree that will have to be read in order to retrieve from that index. So keeping it narrow packs stuff onto the pages and optimizes the way that index is going to behave. Having it wide, having it big, means fewer rows, fewer pieces of information on the page, and therefore more pages have to be read in order to retrieve the data. And that's the main driving force behind keeping it as narrow as possible. Okay, so that's it. You guys are going to stop the recording and we're good to go, right?
Okay.
Thanks for coming, everybody. So do you shut this down, Victor?
I'm here, but I don't have the control.
Okay. I don't either.
Okay.
I would assume, Carmen, are you here to shut it down?